friends, our topic for today is triangles. Today we will be studying about the relationship between the sides and angles of a triangle, and we will be studying about the shortest line segment which can be drawn to a given line from a given point outside it. Now, why do we need to study all these? We need to study all these because we do need this in our daily lives. Suppose you change two sides of a triangle and one side is constant, then how do the angles get affected? And all of you know about the great pyramids of Egypt. What were the different concepts involved in doing such a construction? So until you have a proper concept of all these, such constructions won't be possible. Okay, so let's study about the relationship between the sides and angles of a triangle. If AB is an isosceles triangle with side AB equal to side AC, what is the relationship between some angles of the triangle? Let's draw AM as the bisector of angle A. What do we mean by bisector? Bisector is a line which divides an angle or a line segment into two equal halves. So this AM is dividing angle A into two equal halves. So this part and this part of angle A are equal. Now if we look at triangle 1 and triangle 2, then in these two triangles, AB is equal to AC, it's given. This angle is equal to this angle by our construction, and AM is a common side for both the triangles. So both the triangles are congruent by SAS property. Since the two triangles are congruent by SAS property, the corresponding angles will be equal. So we can say angle B is equal to angle C. If the sides AB and AC of a triangle are equal, then the angles opposite to these sides will also be equal. Angle B will be equal to angle C. Now let's talk about the converse of this theorem. If two angles of a triangle are equal, which two sides will be equal? If two angles of a triangle are equal, then the sides opposite to them will also be equal, and so QR will be equal to PQ. One more way in which this can be said is base angles of an isosceles triangle are equal. What do we mean by the base? The bottom? The base can be any one of the three sides. Suppose I take BC as the base. Which are the angles formed at the base? The angles formed at the base are B and C. In an isosceles triangle, the base angles are equal, and we call the unequal angle the vertical angle. Now let's take an example of an isosceles triangle ABC with AB equal to AC. BM is the altitude corresponding to side AC, and CN is the altitude corresponding to side AB. You need to prove that BN is equal to CN. Now let's identify two triangles which have both BM and CN, and using congruency we will try to prove that BM is equal to CN. So one triangle I'll take is this one with the dots in it, and the other triangle I'm taking is the triangle with these dotted with these broken lines. Okay, now it is given that AB is equal to AC. Since AB is equal to AC, angle B will be equal to angle C. Angles opposite to equal sides of a triangle are equal. Now this angle 90 degree of dotted triangle is equal to this 90 degree of the triangle with broken lines. How do we know this? It's given that BM and CL are altitudes, and you can see that BC is a common side for both the triangles. So we can say that the two triangles are congruent by SAS property. Since the two triangles are congruent by SAS property, BM will be equal to CN by CP CTC. I hope this is clear to you. Now, if I give you a triangle with the sides 3 centimeter, 4 centimeter and 6 centimeter, what can you tell me which is the greatest angle of the triangle or which is the smallest angle of this triangle? Yes, there is a particular theorem about inequality of triangle. We are going to study about that, but there must be some reason why it's happening. Let's do one thing. We will construct BD in such a way that AB and AD are equal. Now since AB is equal to AD, this angle and this angle will be equal. Angles opposite to equal sides of a triangle are equal. Now this angle is the exterior angle for this triangle. For this triangle, this angle is the exterior angle, so it is going to be greater than each of the interior angles. So angle ADB is greater than angle C. Now instead of angle ADB, I can write angle ABD because both are equal. So angle ABD is greater than angle C. Now if we take this entire angle, angle ABC will be greater than angle C because this entire angle is obviously greater than this angle. So we are able to conclude that the greater side in a triangle has the greater angle opposite to it. 6 centimeter is greater than 4 centimeter is greater than 3 centimeter. Which is the angle opposite this 6 centimeter side? Angle B. Which is the angle opposite the 4 centimeter side? Angle A. And which is the angle opposite the 3 centimeter side? Angle C. So we are able to conclude that angle B is greater than angle A is greater than angle C in the triangle. The converse of this is also true. If you have a triangle with the angles 50 degree, 60 degree and 70 degree. Now, which is the smallest angle of this triangle? This 50 degree. And which is greater than this? Greater than this is 60 and greater than this is 70. Which is the side opposite 50 degree? QR. Side opposite 60, PR. And side opposite 70 degree is PQ. So, depending on the size of the angles, the lengths of the sides are also arranged in ascending order. Just now we studied two things. Greater angle in a triangle has the greater side opposite to it, and smaller angle in a triangle has the smaller side opposite to it. Now we will be studying about you are given any 3 points in a plane, can you always join them to form a triangle? If you have been given 3 such points at a distance of, these 2 points are at a distance of 3 centimeter, these 2 points are at a distance of 3 centimeter. So these 3 points, you can see we can join them with a straight line. And since we can join them with a straight line, these 3 points are not forming a triangle. These 3 points which lie on the same straight line are collinear points. And since the points are collinear, you can see PQ plus QR is equal to full PR because the 3 points are collinear. Okay, if the points are not collinear, if they are taken like this, then what will happen? Then you can form a triangle. So 3 points in a plane will either be collinear or we can form a triangle joining all the 3 points. Now, if you have 3 centimeter, 4 centimeter and 7 centimeter as the 3 sides of a triangle, then what are the possible ways in which you can take pairs of the sides? The possible ways are AB and AC, AB and BC, AC and BC. So what is AB plus AC? AB plus AC is 3 plus 4, which is 7. AB plus BC, AB plus BC is 3 plus 7, which is 10. And AC plus BC, AC plus BC is 7 plus 4, 11. If you look at this AB plus AC, is the sum of two sides greater than the third side? No, it is equal to the third side. So, is a triangle possible? No. I told you that if we have 3 collinear points, then only length of this segment plus length of this segment will be equal to length of this entire segment. A triangle is not possible. Now tell me, is it necessary to look at all the 3 possible combinations, the pairs of sides we are taking, or is there a shortcut? Yes, there is a shortcut. If we are talking about sum of 2 sides of a triangle being greater than the third side, then instead of comparing all the 3 pairs, you directly take the smaller 2 sides, and the smaller 2 sides are AB and AC. So if AB plus AC, 3 plus 4 is greater than 7, then only a triangle is possible, which is not true in this case. So a triangle is not possible. What if we have a triangle like this? Which are the shorter 2 sides? Again 3 and 4. So 3 plus 4 is greater than 6, 7 is greater than 6, so a triangle is possible. Now a slight variation of this theorem is difference of any 2 sides of a triangle is lesser than the third side. So in this case, again you may check all the 3 pairs, or you directly take one pair if that condition is satisfied. This condition is satisfied for that pair, your work is done. So which 2 sides will you take in this case? If we are talking about difference, take the greater 2 sides. So the greater 2 sides are 6 and 4. 6 minus 4 is equal to 2. Is 2 less than the third side 3? Yes, 2 is less than the third side 3. So a triangle is possible. Now we are coming to the last part of this chapter, which talks about the shortest distance between a point and a line. Suppose from one particular place you have to go to another place. Then would you like to take the longer route, or you would like to take the shorter route? Obviously, if you are not just wanting to while away time, you would like to take the shorter route. So let's talk about this. Given a line segment AB and a point P outside it, what is the shortest distance between the point P and the line segment AB? Okay, first tell me, what is the shortest distance between 2 points? Shortest distance between any 2 points is the line segment joining them. And the shortest distance between a point and a line will it be the perpendicular distance? Let's see. Suppose I take a point M on AB and draw PM. So what is formed over here? A right angled triangle. Since PM is the hypotenuse of the right angled triangle, PM will be greater than PQ. This angle has to be less than 90, because in a right angle triangle only one angle can be 90. So we are able to conclude that the shortest distance between the point P and the line AB is PQ, which is the perpendicular distance between the two points. Children, I hope you understood the chapter. Do keep practicing maths. Thank you.